All right, question number 3, we got 2 parts. So we have a probability experiment conducted. We're given the sample space, numbers 8 through 19. We're going to let E be the numbers 9 through 14 and F 13 through 16. We're going to list the outcomes in E and F and answer, are they mutually exclusive? So whenever I see E and F, whenever I see the word and, you need to think in common. What do they have in common? So I'm thinking in common. The symbol for and, what you might see is like this upside down U, no tail. It's like intersection. What do they have in common? What do they intersect? So I'm only looking for the elements that E and F share. So looking at E and F, I got 9, 10, 11. This has nothing less than 13. So when I go up to 13, they both have 13 and they both have 14. So E and F would be 13 and 14. That's what they have in common. So I'm going to go here. I'm going to type 13 and 14. And then we want to ask, are they mutually exclusive? Well, if they have anything in common, then they're not mutually exclusive. So if I was to draw a Venn diagram of these two, I would draw E and F, and they would overlap. And what would be in their overlap would be the two elements that they share, which would be 13 and 14. And you can fill in the other elements. So like, for example, F had 15 and 16 that it did not share with E. And then E had 9 through 12. So I can put 9, 10, 11, and 12. So those numbers would be in the part of E that didn't overlap with F. But they do share some elements in common, so they are not mutually exclusive. So we'll say no. E and F have outcomes in common. So either B or C. C is the one that gives us the best explanation. Okay, so number 4, similar scenario. We got a sample space, 5 through 16. F is 5 through 10. G is 9 through 12. We're going to assume outcomes are equally likely. We're going to list the outcomes in F or G, and then we're going to find the probability of F or G by counting the number of outcomes in F or G, and then we're going to determine the probability of F or G using the general rule. Okay. Whenever I see or, it's not either or, okay? We're going to be adding the two groups together. I think total, okay? F or G does not mean what's in F or G. It wants to know what's in F or G or both of them all together. So when I see F, when I see that word or, I'm going to be adding those two sets together. So F is the elements. I'm going to list all those first. 5, 6, 7, 8, 9, and 10. Okay. So once I got that whole group, then I'm going to add to that all the elements of G. Be mindful not to repeat elements. So if something is in G and we already have listed it in F, I don't need to list it again. So starting with G, we had 9, 10, which I already have. I won't add those again. And then we have 11 and 12. So I will add that to the mix. So F or G would be all of F and all of G listed together. If I count this, we got 1, 2, 3, 4, 5, 6, 7, 8 elements total. So we're going to list all of those for answer choice A. If F or G was empty, then we would pick this. That means they have nothing in F or G. They would both be empty sets. So we're going to do 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then we want to find the probability. We're going to type an integer or decimal rounded to 3 decimal places. So how many do we have total in the sample space? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 elements. So when you see that P out front, that P indicates we want a probability. So the probability of F or G is 8, which we counted here, and then there's 12 total. And we can reduce that to 2/3, but since the computer is asking us to round to decimal place, 2/3 should be 0.6 repeating. Turn it on. 8 divided by 12. So we get the 0.6. So 1, 2, 3 decimal places. The fourth one will round up. So we're looking at 0.667. Okay, so last one we want to find the probability and show it with the addition rule. So it says type your expression in the same order as they appear in the original expression. We're going to round to 3 decimal places as needed. Okay, so again, we're going to be rounding these to 3 decimal places. So in that formula, we would do probability of F plus probability of G minus probability of F and G. Okay, so that's the rule. F had 1, 2, 3, 4, 5, 6 elements in it. So we would be looking at 6 divided by 12. If we convert that to a decimal, 6 over 12 is just 0.5. So they want the decimal to be put in. I like the fraction, but system is asking for a decimal. G is 1, 2, 3, 4 elements. So it would be 4 out of 12. So that's 1/3. If we reduce that to decimal form, that's going to be 0.333 repeating, and the 3 will not round that up. So we'll leave it like that. Then we would subtract F and G. Well, what do they have in common? F and G had 9 and 10. So they had 2 elements in common. So 2 out of 12, which is 1/6. I think that's about 1/6 repeating, but let's double check that. 2 divided by 12. Yeah, 0.16 repeating, so we'll do 0.16, and then that will round up to 7. So 0.167 minus 0.167. And when we do this math, we should get the 0.667, which is what we got for the element. So let me punch those numbers in. Clear 0.5 plus 0.333 minus 0.167. We get 0.666 repeating. We got 0.5, 0.333 minus 0.167. We get 0.666.